5, we want to evaluate integrals, and please feel free to choose from 19 through 44 on 395. Okay, I will choose 22. You choose the next one. The integral from 0 to 1, from 1 plus 1/2 u to the 4th minus 2/5 u to the 9th, obviously du. There is no integral without a function, the function and du, or dx, or dt. So first step, we have to identify the antiderivative of each piece. What function prime is 1? Yes, but in this case, u. Excellent, very good. Plus 1/2 times. What function prime is u to the 4th? U to the 5th? 5. Excellent. Minus 2/5 times. What function prime is u to the 9th? U to the 10th over 10. Vertical bar from 0 to 1. So let's see what we accomplished so far here with this problem. Only this piece, this part, in which we have the antiderivative. If you differentiate this function, you will get this for sure. And now we have to evaluate it from 0 to 1. Everywhere I see u, I plug in 1, and then I subtract by plugging 0 everywhere I see u. Luckily, it's 0. I don't have to plug it in. It's all 0. So I only have to plug in 1. And that will give us the answer. So this is 1 plus 1/10. I'll simplify here. Minus 1 over 25. And there is nothing else, because when I plug in 0, I get 0. So the least common denominator is 50. This one needs a 50, this one needs a 5, and this one needs a 2. So 50 plus 5 minus 2. And that is 53 over 50. Now, at this point, we are capable of determining the area under the function 0 from 0 to 2 from x squared plus 1 dx. Last Thursday, we determined this area how? Using the limit of the
It's supposed to be 50 plus 50.
Say it again.
Never mind.
If there is a mistake, I'll rather go back. Am I okay?
How do you
Yes.
factor out the u or remove it? Do you just replace
I
it?
replace u by 1.
Okay.
Yep. So remember we did this last time with the limit of the Riemann sum, and it was a big deal, right? We had a lot of work to do. So now let's calculate. What was the answer? 14 over something. Whatever. 14? No, I would have probably simplified it as 14 over 6.
14 over 3.
14 over 3. Okay, very good. So now let's find the antiderivative of x squared plus 1. What function prime is x squared? Very good. What function prime is 1? Good. From 0 to 2. Do you like this? Or you like the Riemann sum? Very good. So this is 8 over 3 plus 2, 6 plus 8, 14 over 3. Any questions before we continue? Any questions? Is this okay? Good. Let's move on. What about, yes, any preference? Yes, what about 32? The integral from 0 to pi over 4 from secant theta tangent theta. Secant theta tangent theta, d theta. Which function prime is secant tangent? Which function I differentiate to get secant tangent? It's secant, right? Secant theta from 0 to pi over 4. Let's refresh our memory. When we differentiate sine, we get cosine. When we differentiate cosine, we get negative sine. When we differentiate tangent, we get secant squared. When we differentiate cotangent, we get negative cosecant squared. When we differentiate secant, we get secant tangent. When we differentiate cosecant, we get negative cosecant cotangent. Right? So that's it. I plug in pi over 4. So this is secant pi over 4 minus secant 0. Okay, remember, we normally don't think in terms of secant. What we do is change secant into 1 over cosine. So we do know cosine pi over 4, which is excellent. So it's going to be 1 over the square root of 2 over 2 minus. We do know cosine 0, which is, so then 1 over 1 will be negative 1. I flip the denominator because I divide by a fraction, 2 over the square root of 2 minus 1. Yes, we should rationalize this as 2 the square root of 2 divided by 2, multiplying by the square root of 2 and by the square root of 2 top and bottom, and minus 1. So the final answer is the square root of 2 minus 1. Any questions? Yes, Ricky, go ahead, please.
So what about the tangent?
You're talking about this tangent?
Yeah.
Okay. Secant prime is secant times tangent. So the antiderivative of the product secant tangent is secant. Better? Yes? Okay, let's look at, I would like to look at problem 44. Any questions? Anyone, any questions? Okay. So 44. So this is 11. In 44, we have the integral from negative 2 to 2 from f of x dx. And they are giving us the function f of x as being 2 for negative 2 less than or equal to x less than or equal to 0, 4 minus x squared for x greater than or equal to, no, x greater than 0 but less than or equal to 2. I'm going to write out that, sorry. So for x between 0 and 2. So they're asking us to determine the integral from negative 2 to 2 from f of x dx. F of x is 2 for x between negative 2 and 0, and is 4 minus x squared for x between 0 and 2. What do you think we need to do here? What will this equal to? Obviously, the integral from negative 2 to 0 plus an integral from 0 to 2, because they are from different functions. So the integral from negative 2 to 2 is not from one particular function, but from two functions. One that goes from negative 2 to 0, and the other one from 0 to 2. What would be the first function? Or the first integral? What do I write? The integral from negative 2 to 0 from what? What is the function? Exactly, 2 dx. Awesome. What about from 0 to 2? Exactly. We are using one of the properties of the definite integral because these are two functions. It is a piecewise defined function, but still is made up of two different functions. Very good. So now what is the antiderivative of 2? You know, you can say move 2 in front, and then I'm going to ask you what is the antiderivative of 1? Indeed, x. Very good. From negative 2 to 0 plus. What is the antiderivative of 4? 4x. What is the antiderivative of negative or x squared? X cubed over 3. Very good. From 0 to 2. Awesome. Good. Remember the properties and remember how fundamental theorem of calculus part 2 is teaching us to evaluate this. I plug in 0. So keep the constant outside. I plug in 0, I get 0. Minus when I plug in negative 2, but that changes into 2. Plus, when I plug in 2, I get 8. Minus 8 divided by 3. I should write minus when I plug in 0, but everything is 0 when I plug in 0. So then I have 4 plus 8 minus 8/3, which is 12 minus 8/3, or 36 minus 8 over 3. 28 over 3. This is the area under the graph of the function f of x. That is a piecewise defined function between negative 2 and 2. Some area between negative 2 and 0, and some other portion between 0 and 2. Yes, Brayden, go ahead.
What happens to the 2x?
I plug in 0, I get 0. I plug in negative 2, I get negative 2, but with minus in front changes into positive. Is that better?
Yeah.
Other questions here? Other questions? Okay. I'd like to discuss now, we're going to have more definite integrals in a minute. But I'd like to discuss now definite integral, indefinite.
This is the question.
Yes. Indefinite integrals. Nothing new. You'll see in a moment what I'm trying to do. On page, I'm trying to start with something practical. And nice. And I can't find something nice to start with, just a starting point. I will have to make one up. Okay, so here it is. And actually, I can go back to any function that we already looked at. The integral, let's say, from x squared plus 1 dx. This is a function, basically a family of functions. So x squared plus 1 dx. Can anyone give us the antiderivative of x squared? Plus the antiderivative of x, of 1x, plus a constant c. This is the way we calculate indefinite integrals. This is the only type of integral that I can check. We can check the answer that we get for a definite, for an indefinite integral. And this is part 1 of the fundamental theorem of calculus. I'll explain in a minute. But never the answer of a definite integral. I have no way of checking this number. Yeah, we did it in 2 ways, so it's very unlikely that there is a mistake. because we looked at it in two different ways. But if you ask me, if you give me a number, if you give me the beginning, and if you give me the answer of a definite integral, I will not be able to check. I would just go start from the beginning, and hopefully I'm getting the same answer. However, for indefinite integrals, we can always check. Why? Because we're going to use part 1 of the fundamental theorem of calculus that says that differentiation and integration are inverse operations. Meaning, if I differentiate the left-hand side and I differentiate the right-hand side, I should get the same thing. Forget about the left-hand side for a moment. What will you get when you differentiate the right-hand side? Can anyone give us the derivative of the right-hand side?
X squared plus
Right. So what happens on this side? Differentiation removes the integral symbol, and with it, the width of the subinterval, the x. And the answer is x squared plus 1. So I can always check an indefinite integral, the answer of an indefinite integral, but I can never check the definite integral. Okay, so let's look at, these are all already with substitution rule, and I will present substitution rule in 5 minutes. I just want to choose another problem without the substitution rule. Okay, I did get it. I did find it. Okay. Yes, please.
You're saying if you differentiate the left side?
If I differentiate the left-hand side, this operation removes this and removes this. So all I'm left with is the function. And on this side, when I differentiate, I get x squared plus 1. Okay, on page 404, let's look at number 12. So we have an indefinite integral, which means no limits of integration, which means the answer is a function. The integral from x squared plus 1 over x squared plus 1 dx. This we can check by differentiating both sides. Which function prime is x squared?
X cubed
Over 3 plus. Which function prime is 1?
X.
Excellent. Plus. Which function prime is 1 over x squared plus 1? Arctangent x plus a constant c. Very good. When we differentiate arctangent, remember this is a very important piece, especially for Calc 2. Arctangent prime is 1 over x squared plus 1. So we can differentiate both sides and we will get the same thing. Any questions? Any questions? Okay, I think it's beneficial now to look at the substitution rule for both definite and indefinite integrals, and then come back and discuss some more about fundamental theorem of calculus part 1 that teaches us that differentiation and integration are inverse operations. So let's look at the last chapter, last section of this chapter, 5.5, the substitution rule. Yes, Ricky, please go ahead. We're going to come back to 5.4. It's still the fundamental theorem of calculus. Okay, so let's start with indefinite integrals. What is the difference between f prime and dy? Say it again.
There's like a really small difference between them.
So f prime represents the derivative, right? Agreed? Okay, so this is the derivative. What does dy equal to?
It's approximately divisible by.
So what is the definition of dy? How do we calculate it? We had it in chapter 3. Say it again. f prime of x dx. So please realize that these are two different things. However, this is the same with dy over dx, but I'm only talking about dy here. So just cross multiply. So yes, we know that f prime of x is the same with dy over dx. But when we talk about the differential of y, we mean this product. How do you get it? Just cross multiply, and you get dy equals f prime of x dx. But these two are not equal. I need this for the substitution rule. I need you to understand that f prime is one thing, dy over dx, but dy is f prime of x dx. See the difference? So dy is only this piece. F prime of x is the ratio. Cross multiply, you get this. Is that clear? Okay. So when do we ever use a substitution? When would I ever think of using a substitution? Only if it simplifies the problem. If it doesn't simplify the problem, why would I ever substitute? To make it more difficult? No, right? So I would always think of a substitution if it simplifies the integral, basically the function inside and the whole thing, f of x dx. Otherwise, I would not think of substitution or substituting something, right? So let's start with simple examples and see how we apply and what we do. Okay, let's say on page 413, I would like you to choose anything you want from 1 through 48. If not, I will. So we start on page 413.
2.
Which one?
2.
Number 2. Evaluate the integral by making the given substitution. Okay, number 2, we're given x cubed 2 plus x to the 4th, everything to the 5th power, times dx. They are giving us, this is very unique situation and very simple situation. We are given the substitution. We will not be given the substitution. So that's a very good starting point. Okay, so what would you normally do or think of doing? You will raise this to the 5th power. You will get 6 terms in 10 minutes, and then distribute x cubed, and then find the integral. No, that's not what we want to do. So why do we use this substitution is because this is the most difficult part in this function. Why? Because it's raised to the 5th power. This would have been very simple. I would have distributed and gotten the antiderivative and the function in a blink. But this power 5 creates the problem. This raised to the 5th power will have 6 terms. It's going to take me a long time to determine them, right? So unless I use Pascal's triangle or combinatorics. But other than that, if I do it by hand, it's going to take a while. So this piece then, all of a sudden, will become u to the 5th. If we make the substitution that 2 plus x to the 4th is u. So then all this piece becomes u to the 5th. Do you agree so far? I cannot have u and x in the same problem. So obviously I have to determine du. Can anyone give us du? And remember what du means. It means the function prime times dx. So can anyone give us the derivative of this? 4 x to the 3rd dx. Do I have du in the problem? Yes. I have dx. I have x cubed. The only piece that I don't have is the 4. The 4 is not a problem ever. Multiplying by 4 and dividing by 4 creates what I need, and it's just 1. I multiply the top by 4 and the bottom by 4. And now I have exactly what I need. So can anyone dictate a new integral with 1/4 in front? The integral from excellent, u to the 5th times what is this, this, and this?
du.
Exactly. And I'm done. which is 1/4 u to the 6th over 6 plus a constant c. Yes, for indefinite integrals, I have to go back to the variable that was given to us. So I have to write the answer as 1/24, 2 plus x to the 4th, everything to the 6th, plus a constant c. With indefinite integrals, I have no choice. I have to go back and present the final answer using the given variable. This was a good warm-up. Yes, please.
I don't understand where the u came from. Does the x cubed go away?
So 4x cubed times dx will be all replaced by du. This piece is u to the 5th. I cannot have an integral without the symbol, without the function, and without du. So once this changed into u to the 5th, then I'm trying to figure out what do I change this into, because I cannot have u and x in the same problem. Since the integral in u will not exist without du, I need to have du. And du is exactly what is the remainder. The remaining factors are du. Better? So then 1/4 is in front, and then this becomes, the antiderivative is u to the 6th over 6. So then we get 1/24. It's u to the 6th, but I have to go back and replace u by 2 plus x to the 4th to the 6th power plus a constant c. Is that better, everyone? Okay, this was just the first problem. Very good. Let's move on. Let's look at problem 14. Same page. The integral from u, the square root of 1 minus u squared du. You can use any substitution you want, any letter you want. But the idea is that du must be in the problem. So if you use t, that's fine. dt must be in the problem. What do you think our substitution would be? Before you answer, let me say this. This is very nice and friendly. This is very nice and friendly, but only if it's applied to one term. If it has two terms, I'm stuck. I can separate them, I can simplify, I cannot do anything to it. So which portion of this function you would like to denote by something else to make the function easier to work with?
1 minus 6.
Absolutely. So I'm going to say let t be 1 minus u squared. Only if dt is in the problem. If dt is difficult to create, either plus or minus some number, some factor, then this is not the right substitution. Or it could be not the right substitution. So what is dt?
2's negative.
Negative 2 u. Excellent. Great job. Indeed. So it is negative 2u du. Now look, careful. I have the u. I have the du. I don't have the negative 2. But that's not a problem. Negative 2 times 1 over negative 2. So I put a negative 2 in front, and now I have everything I need. So I have negative 1/2 in front and the integral. And please tell me, what will you write? Remember, once we moved away from u, all u's go away. I can't have u anymore. So what do I write? What do I replace this by? Square root of t, indeed. What do I replace negative 2u du by? Excellent. And now this becomes a piece of cake, because it's t to 1/2 plus 1 over 1/2 plus 1 plus a constant c. So the square root of t means t to 1/2. I have to increase the power by 1 and divide by 1/2 plus 1. Yes, I have to clean it up and do the arithmetic here, but it's pretty much done. Any questions? Okay, let's clean it up. So I have a negative 1/2, but this in the denominator will be 3/2, and I have to flip it. So 2/3, and t to 3/2 plus a constant c. I will simplify by 2, and I get negative 1/3. And yes, I have to go back and replace t. 1 minus u squared raised to 3/2 plus a constant c. And that's the final answer. Yes, Ricky, go ahead.
Why did you put?
Yes?
Why did you put -1/2?
Because, see, dt is not just u du, is -2 u du. So I have to have a -2. So it's like I'm giving you -2 and I'm dividing by -2. So multiplying the top by -2 and dividing, or multiplying the denominator by -2 will not change anything. This is 1. This is 1. But now -2 u and du give us dt. And then I have to have the -1/2 in front. And this piece changes into the square root of t. At the very end, I have to go back and replace t by 1 minus u squared. Is this better?
Yeah.
We need practice. So that's what we're doing. 24. We have the integral from the square root of x sine 1 plus x to 3/2 dx. Again, we're trying to find a substitution here. And here's what bothers me. And this is not the scientific way of thinking, but this is the easiest one to understand. What bothers me is this huge function inside sine. That's what bothers me. I like sine to be clean, sine x, not sine of another function. If I could get rid of that, maybe I'm on the right track. So what do you think we should denote by? Any letter you want except x. Let u be, what would you like to see disappearing?
1 plus.
Yes, I would love to see this disappearing. But again, the problem relies on the existence of du. If du does not exist or is difficult to create, then I'll be in trouble. This may not be the right way. Good. So what is du? Equal to. So 3/2 x to 1/2. That's not enough. Careful. Remember, du is dx. Very good. If we forget the x, then we're not finding the differential of u. So now please tell me how to change this. So remember, x to 1/2 is the square root of x. So I have the square root of x, I have the x, but I don't have 3/2. That's really not a problem. Multiplying by 3/2 and by 2/3 means multiplying by 1, which will never change anything. But now I have the 3/2, I have the square root, and I have the dx. These three pieces, 1, 2, 3, make up the du. And now I have sine u. It can be easier than this. So 2/3, the integral from sine u du. Yes, Brayden, go ahead, please.
Why did you multiply by 3/2?
I need this. I don't have it.
I don't understand what you mean by that.
So du has to be in the problem. This piece I have. This piece I have. But I don't have 3/2.
Isn't that 1 plus x 3/2?
But this is inside. This is inside sine. All this is sine u. I can't touch that. This is the sine and its argument. This is not outside of sine. It cannot be considered. Right? So this piece is just one whole. This is just sine u, nothing else. So du has to have these three factors. It has dx, it has the square root of x, it has dx, but I'm missing this piece, this number. So I'm multiplying by 3/2 and by 2/3. This number is 1, is not going to affect anything. But now 3/2, the square root of x, and the x, they all form du. What is left is sine u. and the integral, but of course I have a 2/3 left outside. I have no choice. I can't make that disappear. Is this okay? So then this is 2/3. Which function prime is sine u? But negative, right? Very good. So negative in front, cosine u plus a constant c. So negative 2/3, I have to go back and replace u. What am I replacing u by? Exactly. 1 plus x to 3/2 and outside constant c. Let's come back to the problem one more time. Is this clear why I cannot separate these two? Yeah, because these are together. This is the sine u. But now I need to form a du. If I don't have du, one other way is to solve this equation for dx, which I think is slightly more difficult in certain cases. Instead of saying I have du, I have this factor, I have this factor, but I don't have 3/2. So multiply by 3/2 and divide by 3/2. Another way will be to, as I said, to solve this equation for dx and plug it in, but I think it's slightly more difficult. Okay, did we get the idea with indefinite integrals? Can we look at a definite integral with substitution? Or you can say, no, we only have 5 more minutes, let's practice this, and we can do on Thursday, we can look at and wrap up this chapter with substitution rule in part 1. So should we still work on indefinite? Okay, let's still work on the indefinite. Okay. What about 34? In 34, we have the integral from cosine pi over x, everything divided by x squared dx. So what do you think the problem is here? What bothers you? Over x. Yes, that bothers me. I would rather see cosine t than cosine pi over x. Very good. So then I will let t, or any letter you want, y. Let y be pi over x. But keep in mind, dy must be in the problem, or plus or minus a factor, not more. So when we differentiate pi over x, keep pi outside, differentiate 1 over x. Pi is a constant. When we differentiate 1 over x, we get? Excellent. Negative pi over x squared, and then? Very good. Let's see what we have and let's see what we don't have. Obviously, you will say that this will be replaced by? Cosine y, right? I cannot eliminate cosine from there, right? So this is cosine y. Good. I have the x. I have the denominator of x squared, but I'm missing this piece, the negative pi. Negative pi, 1 over negative pi. I multiply the numerator by negative pi. I multiply the denominator by negative pi, which means nothing. I didn't do anything. But now I have these pieces. I have negative pi over x squared times dx. Those 3 pieces form the dy. These. All this is dy. The negative pi at the top, the x squared in the denominator, and dx following. So then I have negative 1 over pi, the integral from? Yes, cosine y dy, excellent. What function prime is cosine y?
Negative.
No, that's just positive, right? Sine y plus a constant c. All I have to do now is replace y by? That's it. You got it. Yes, we have to get used to it. We have to practice, but you got it. Negative 1 over pi, sine pi over x plus a constant c. We have time for one more. Let's do another trig one. Would you like number 40? Is number 40 okay? Okay, let's do 40 and then we can stop. 40. The integral from sine x over 1 plus cosine squared dx. Now, if I ask you what bothers you, you'll say, well, nothing, because this is sine x, this is cosine x. It's not a function inside another function. But if you look again, you will see that you are bothered by a denominator with two terms. I am bothered by a denominator with two terms. I like a denominator to have one term, so if I want to separate, if I want to do whatever, but I don't like two terms in the denominator. Okay. However, if we go on that route, then when we differentiate this, we'll have 2 cosine x times negative sine x. So dy will be difficult to create. So I have to think of a different route. It is cosine squared. So the option that I have in mind is to let y be cosine x. But what is dy? What is the derivative of negative sine x dx? Is this in the problem with minor change? Yes, sine is here, dx is here, both at the top. I am missing this minus, no problem. I multiply by -1 twice. And then, what do I have? Negative outside. Can anyone tell us what to write inside? Angelina, can you tell us what to write inside? Mark, can you tell us what to write inside?
Would it be a
Yes?
dy over
dy over 1 plus? Very good. Indeed, y squared. So negative outside, the integral from dy indeed, because it's -1 times sine times dx, which is dy, and the denominator is indeed 1 plus y squared. What function prime is 1 over 1 plus y squared? We had it 3 minutes ago, 4 minutes ago, or by maybe 10. Very good. Arctangent y plus a constant c. So I have to go back and replace y. What am I replacing y by? Cosine x indeed, plus a constant c. Excellent. Well done.